Well, yeah, because they know that 14 is 2 times 7, right? So they can unscramble it. With me? You get the idea so far? Okay, now imagine that the number I yell to you is 80 digits long. 80 digits long. So what I do is I come over here, and do you remember I told you the prime numbers, that they're infinite, that the list goes on forever? What I do is I find two 40-digit prime numbers. I go find them, okay? And then I multiply the two of them together. And what that creates is an 80-digit prime. And that's what you hear me yell, the 80-digit prime. You use that 80-digit prime to scramble. And then you yell back the scrambled message. They hear it, and they say, shit, I've got to find a way to break that 80-digit prime number down into the two 40-digit numbers it came from. All right? Do you think that's easy? It turns out that it's extremely difficult to do. In fact, if you somehow got a computer working on it, right? The idea of using like I use 40-digit numbers here, right? Could I have used 20-digit? Right? I could have. I could have used 80-digit numbers. I could have used 100-digit numbers. This number right here of how big I pick my primes is totally dictated by the computing power in the world at the time. So right now, in the world, if I use two 40-digit primes, multiply them and get an 80-digit number out here, it would require every computer on the planet trying to break the code at the same time, and it should take approximately the age of the universe for that to happen. Does that make any sense? Like, that's the whole idea these guys came up with. RSA, these are the initials of the last names of the guys who came up with it. The whole idea is that we're just going to make these numbers big enough where there's just no way it can be broken by any computer. There's no way. All right? So what happens when computers get faster? Just go bigger. Just go bigger. And eventually you get big enough where computers can't process it. So that is the way when you send your money, banking, right? You hear about, like, you know, terrorist organizations, and they've got these apps on their phones that the CIA can't break into their phones and things like that, encrypted. Like, you want to believe that there's some secret agency somewhere that can break in. They can't. You can't break this, okay? You can't. And it's so powerful, in fact, that when it first came out, if you had the program, like on a flash drive or something, if you had the program and you tried to leave the United States with it, they considered it transportation of a munition. So it'd be like the same as trying to carry like a rocket launcher out of the country. Like, that's how scary it was in the beginning when it was first kind of thought of. So why am I telling you this story? Because it all comes down to a very fundamental principle, prime factorization of a number. This is easy when it's 14. It's not easy when it's 80 digits. In fact, everything in the world that needs to be secure is founded on this basic idea right here. So if you could come up with a way to break down an 80-digit number into two 40-digit numbers quickly with some sort of algorithm, you would probably be dead pretty soon, and someone would take that and use it somewhere else. But I mean, you know what I'm saying? Like, you could bring all the financial institutions down, you could bring everything down if you could figure that out. I'm not telling you that's how it would be used, but just saying nothing would be safe anymore over the internet. Nothing would. Okay, so if anyone here ever figures that out and becomes very rich, I want you to remember that I was the one who told you about it and inspired you. Yeah? Oh, is it time? Oh, y'all are packing up, like, sorry. It's not time. I just went off on a random tangent. Sorry. We still have a little more to do. I apologize. Apparently, my storytelling is pretty soothing. I put a couple of y'all to sleep. It's okay. All right, so you can do your homework on that. We need to talk about percents. All right, percents. So we've all heard of percents. My goal here is to try and help you understand, make sure you understand what percents really are, what they mean. So we're going to do it with our own little poll here. And this is always a very interesting poll. So let's first see how many people we have. We have 2, 5, 8, 12, 16, I can't do math, 24, 25 of us in here right now, okay? So there's 25 of us in here. How many of you use an iPhone? Okay, let's do it the other way. How many of you don't use an iPhone, use like an Android? Okay, so 1, 2, 3, 4, 5, 6. I think that's the most I've ever seen. So 6 are doing Android? Okay, is there another option? And then that means 19 are doing our slaves to, I'm sorry, I'm kidding, come on. Jeez, I'll probably lose my job for saying something like that. Apple coming down on me, right? So, percentages. What percent of us use iPhones? So what do we mean? And like, how do we compute that? So a percentage, go ahead.
Like, I wouldn't know like a proper way to do it, but since there's 25 total of us, that's 1/4 of the 100. You know, just like.
Okay, yeah, I know what you're doing. You're trying to turn it into 100. I'm going to try and do that without even doing that part. So when we're looking at a percentage, what we can look at is what part that we're talking about divided by the whole. So for us, the part, if we're saying how many of us use iPhones, then the part of us that use iPhones is 19, right? And that's out of the entire whole, all of us, which is 25. And then what we do is we get on our calculator and we type this in. So somebody type that in, 19 over 25. We might get a repeating decimal here, or decimal. What do we have? Go ahead. 0.76, and it stops right there? Okay, so this is exactly, I'm going to put 0.76. All right? So this is the decimal answer. This is the decimal answer. Now, this is going to go back to basic elementary school that you may or may not remember. When we see a decimal, this first number is how many tenths we have, and the second number is how many hundredths we have. So this is really saying that we have 76 hundredths. But that's not important. What's important is for us to convert this to a percentage. So do you all remember? I see it, yeah. How do we convert decimals to percentages? We take the decimal point and move it 2 places to the right. If we're going from decimal to percent, we move 2 to the right. So we're going to make this 76, right? Boom, boom, 76%. Right, 76%. 76% of us use iPhones in this class. Now, you could find how many use Android by doing 6 over 25, right? Or you could just use the idea that it should all add up to be 100%, right? So what percentage is left? 24%? So 24%. I actually am very surprised to see this 6. I think the last few times I've done this in class, it's always been just me and maybe one other student that have Androids. So maybe the tide is turning a little bit here. Okay, so when we talk about percentages, we're talking about parts out of a whole, right? And then we're converting that decimal into this notation. Now, what's confusing about percentages is that, or it can be confusing, is that when you say 76%, what you really mean is 76 out of 100. Okay, so that's what 76% means. It means if you were to look at this situation, this room, 76 out of 100 would have iPhones. The problem with the percentage is that it's basing it out of 100, and there's not 100 of us in here, right? It's saying if there were 100 of us in here, 76 of us would have iPhones, if there were 100, all right? So percentage means out of 100, but for us, finding a percentage is going to be finding the part over the whole and then taking the decimal to a percent. Okay, now, let's take a look at these word problems. or not word, they're word problems, but they're not really word problems. These are problems where they give you a statement and you're supposed to figure out the answer. You're guaranteed you're going to have these on the test. So look at the instructions to this. Zeke? Okay. Can you read the instructions so everyone, can you read it okay? Or can you see it?
Write each of the following as equations.
Okay, stop right there. The instructions say to write each of the following as equations, right? It's not just saying solve the answer. I don't want just the answer. I want each of these to be rewritten as an equation. That's part of what I expect to see here. And then after that, you solve, all right? So when you look at this right here, what percent of 200 is 21? There are key words in here, and in mathematics, certain words mean certain things. So when you see something like what percent, that's what we're trying to find out, right? What percent? What percent? Let's call that X. So this is like X. Okay, when you see the word of, what do you think that stands for? I can't hear. I'll give you a hint. It's an operation. It's either addition, subtraction, multiplication, or division. It's multiplication. The word of is multiplication. All right, so X, what, times 200. What do you think the word is means? Equals. Is, right? It is. It's equal to 21. Do y'all see that? What percent times of 200 is equals 21. Now this equation, can you solve this? I'm going to write it over here. X times 200 equals 21. Kayleen? Where's Kayleen? How would you solve that? That's a linear equation in one variable, right? Divide 200 on both sides. So let's go ahead and do that. Do 21, divide by 200. I need someone on their calculator for that. Go ahead. Does it keep going, the decimal, or is it nice and clean? 0.105? So I'm going to write 0.105. All right, so is that our answer? So we wrote the equation. Did we solve it? Yes, but what was it that they were asking for to begin with? What percent? What is our answer? It's a decimal, right? So we need to convert our answer from a decimal to a percent. So converting that, you get X is equal to 10.5%. Just move that decimal point 2 places, right? What I like to do at the end is come back in here and kind of plug my answer in and see if it makes sense. So like 10.5%. Does it make sense? 10.5% of 200 is 21. What's 10% of 200? 20. So 10.5% should be a little bit more than 20. So the answer makes sense now. Okay, let's try the next one. I want the equation. Look, on the test, people are going to give me an answer. They're not going to show any x's or variables or anything. They're just going to give me an answer, and you're going to get partial credit, but you're not going to get full credit because you have to write the equation. I'm asking you to do that. Kristen's up.
So I kind of do things a different way, and I actually wanted to ask you if it'd be okay if I do it.
Okay.
I'm used to doing percentages as proportions.
Mm-hmm.
So for example, for that previous one, I did 21 over 200 equals x over 100. So then my equation is 21 times 100 equals
Sure.
21,000
That's okay.
divided by 200.
That's
So
okay.
that's the-
Are you writing the equation out, or are you writing a different equation?
I wrote that exact equation, like, cross multiplying and then dividing.
Yeah.
And I got 10 points.
That's okay. Yeah. What you're doing is you're accounting for this moving of the decimal point.
Right.
You're accounting for that in your math. So to move the decimal point to the right twice, you're multiplying by 100.
That just
Yeah.
makes it a little easier. for
Okay.
me. So
Yeah, that's
how I
fine.
do it.
Now, how about translating this into an equation?
Right, so I would set that up as, let me see, how do I write that? 15 over 100.
Okay, so 15 over 100.
Right,
So
you're trying to find
what
the-
she's saying is when she says 15%, she writes it as 15 over 100. Okay? If I were doing this, and this is not any more correct, I would write 0.15. But they're the same thing. These, if you take 15 divided by 100, you get this. Okay, so I'm okay with you rewriting that this way. And then what?
And then I would write equals 19.5 over x, because you're trying to find.
I see what you're saying now. Okay, so I'm with you, but in terms of just satisfying what I'm doing here, if I say of a number, what's the operation here? Of is multiplication, right? So times, and then a number, x, and then is equals, and then this number is 19.5. So I'm okay if you do it a way that you're comfortable with, as long as you're working with an equation. What I don't want is just like an answer.
After I did the proportion.
Yeah,
That's how I write it down.
that's fine. That's fine. That goes for everyone. If you're working with something you're comfortable with, as long as you're working with an equation and solving it, I'm okay with that. All right? But if you're kind of like, what are we doing here? Then I want you to try and follow what I'm doing with this. Converting that, let me make it a decimal. 0.15. So I'm doing 0.15 times a number x is equals 19.5. And that is an equation, right? And how would you solve this for x? No, we're moving on to Devin's up. So if I have the equation 0.15x equals 19.5, how would you solve that for x?
Could you take away the 0.5 or
How do you take away the 0.5? How do you mean take away?
like minus 0.5 over the other one or no?
Well, I want you to think about that. If you're subtracting it, right, what is the operation? You're trying to get the x by itself, right? What is the operation right here?
Oh, that's multiply.
So how do you undo multiplication?
Yeah,
Divide.
Yeah.
Okay, so we're going to divide by 0.15 and then divide by 0.15. So on your calculator, you just have to do that. All right, Rodrigo, just say if you're here or not. Rodrigo, Damien, Heidi, Evan, Victoria, Sylvia, Becca, Josh, Vince, and Alex. Alex? No Alex. Okay, so those of you who were not called on today, I will call on you next time. For your homework, definitely do the homework off of the GCF and the polynomial stuff. If you want to start the percentages, you can't, but there's some word problems that we haven't talked about yet. So you may get hung up with that. But you can maybe start it. Let me see what the first few look like. Like numbers 1, 2, 3, 4. Maybe the first 4 you can try on the percentages. But that's where we'll pick up next class, all right? Everybody have a great day. See you on Wednesday. Remember to look for that review. Hey, I have not given y'all a quiz in class yet because the test is happening so soon, but from afterward, I would expect quizzes more frequently. All right. Alex, yes.
I have a question about the percentages.
Okay, give me just a second. Let me just finish marking this off. And Christian. Where's Christian? Yeah, and let me turn my camera off. That way you can talk and not worry about that. Go ahead.
Oh, sorry. Thank you. Have a good day.
You too.